Greetings and welcome back to the lab. We have another hack for this not so musical device. After doing a little bit of analysis, and we'll dive into that a little bit later, what I ended up discovering was that the 2K, 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 1K, 10K does not give you a musical scale. I looked at the circuit, I did a little bit of analysis between whether it's a monostable or an astable multivibrator, which is just the type of circuit that's being used here. Either way, those resistors are not going to give you a musical scale. So after a bit of analysis and calculation, I've come up with a new set of resistors that should give us something closer to A, B, C, D, E, F, G, and another A. This does not have sharps or flats. This is going to just be a natural scale. I'm not sure if it's really supposed to, in do, re, mi, if that's supposed to start with A or with C when it comes to musical scale. But ultimately, I'm going to go to A440 and bring it up to A880. Using an equal tempered scale, something that you can look up if you want, or maybe I'll provide some links to Wikipedia articles and such. But the key here is to get it from this sound to something a little bit more natural sounding, a little bit more musical. So I'm going to go do that build, and then we'll come back, we'll test it out, we'll see if it sounds a little bit better, and then I'll explain what I did. Alright, it's been a few days. I've had other projects to deal with, but I did get this done. I will post somewhere, maybe I'll give you a list of the actual resistors that I came up with, the values that were needed to do this, but it does seem to have worked. So the one downside I've noticed, and I think I just mentioned this a few days ago, is that having this plugged in for a period of time, this detects that not a lot, if you're not actually playing this, it detects that not much current is being drawn, and it shuts itself down. It just requires a minimum amount of current before it'll actually operate. So I'm going to go ahead and plug this in and play it for you real quick. Okay. That may not sound terribly, terribly musical, but as a first step, let me just sort of prove this. One is half of the other. That is how octaves work. I set this up so that this is an A at 440 Hertz and this is an A at 880 Hertz, which are the proper frequencies for A. So A, B, C, D, E, F, G, and then A again. It's going to continue to go up. And once again, if you listen to it, they may not be absolutely perfect pitch because I had to use resistors that were close, within, let's say, about 5 Hertz of the desired frequency for an equal tempered scale. But it's a good start. And while for the last few days I haven't been able to get back to this, and actually the speaker managed to come, the wires are kind of cheap, so they came off. I had to resolder it just now, but that proves that it works. I'm going to go ahead and unplug it. I do have a thought, fairly simple thought, for how I can actually make this stay on, so that if you play a bit and then you have a few moments when, like if you're trying to play real music, and there's a pause in the music, that you're not going to have this shut off on you while you're in that pause. But I think all I'm going to do is add an LED here. I know what I want to do. I haven't figured out exactly how I'm going to do it, but that's the next modification for this. Then beyond that, we might look at maybe an amplifier. I don't know if this speaker is really very good. I know that this is generating a square wave. I might add a circuit. I've found circuits that I can add that would convert the square wave to a sawtooth wave, and then from a sawtooth wave I can make it to a sine wave. But it gets more and more complicated, so I'm trying to do the simple hacks first, and then we'll see if we can build this thing out to be something a little bit more useful. The other downside to a simple project like this, so maybe we can't go too far, is I'm going to go ahead and plug this in and show you that if I hold down one key and then I try to hit another key, I'm not going to get a response here. Well, okay, I am, but I'm not going to get both of them at the same time. Let's see, 1, 2, 3, 4, yeah. First and fifth, that would be a power chord on the guitar. If I push them at the same time, I get whichever one actually clicks first. So if I do it with a slight delay, oh, okay. I take that back. Now that I think of it, actually makes sense. It's always going to go with the higher note if you try and do two of them at the same time. The only way you're going to get two notes is, and then let go. So that's what this hack does for you. Let's see what else I can come up with.